Hi, sixth grade science students. This is Miss Janier, and I'm here to give you a little extra help if you had some trouble with your binary code introduction on Friday. Now, some of you have not submitted the assignment, and your science teachers have decided that maybe it's because you were stuck and you need a little extra help. Others of you might have submitted it, but you got enough wrong or you seemed a little confused that your science teacher wanted you to do a quick review. What I'm going to do today is I'm going to go through this activity for the beginning of it with you to get you started. So you might want to pause the video and open up that activity so that you can have it up on the screen, and you could be watching me do the activity and you can do the activity yourself at the same time. When you're done doing the activity, watching the video, I'm going to leave you off about more than halfway through, and you're going to finish up that task. And then you're going to submit that to your teacher so that you can get that graded and that you can start on your work for Monday. The activity for Monday and all the rest of the week really is based off of your understanding of this activity. So we want to make sure that everyone has a good solid base and understanding about binary numbers so that when things get a little more complex, that you're going to be able to keep on going. Now, this activity is called the binary number introduction. Earlier last week, you did the 7-segment display where you saw open and closed circuits, and we represented those open and closed circuits first by on and off, like all digital signals, and then we started abbreviating the on and off to zeros and ones so that we introduced that code to you. Now, it might seem pretty easy to think about a scoreboard with 7 circuits and being able to code for that on and off their lights. But for the most part, when we're talking about computer coding, we're not talking about just turning on and off lights. It's much more complex than that. And the question we have here is, how can just 2 numbers allow you to have the complexity that we need to do everything we need to do for digital signals? As you know, we only have 2 letters in the binary alphabet, and those letters are 0 and 1. So we're going to go through different length numbers to see how we can start getting lots and lots of possibilities pretty quickly. So if you have a 1-digit number, which means you only have 1 numeral, in binary, you would be able to have either a 0 or a 1. So on this, we have these cute little cards, and we're allowing you to drag them in, and you can see that one of the options that you would have for a 1-digit number would be the number 0. And then if I drag this one over, the other option that you would have is 1. That didn't move. Let's try that again. Would be 1. Okay? And so you have 2 options for a 1-digit number, which doesn't let you do very much, as you can imagine. When we move ourselves to a 2-digit number, our options are still 0 and 1. You can either put a 1 in one of the digits or a 0. Now, many of you think, well, if there are only 2 options, 0 and 1, and there are 2 digits, then there's 2 options. But actually, order matters. So I can make a numeral that looks like this. And that would be 0, 0. And in this red box here, what I want you to do is put your options. So our first combination that you could make with 0 and 1s in a 2-digit number are 0 and 0. Now, I can make a new number, and that's 0 and 1. If I take that 0 off, I can get 1, 1. And now, just to be interesting, if I take that 1 away, we'll put the 0 back, I can get 1, 0. And so for a two-digit number in binary, there are actually four combinations you can make: 00, 01, 11, and 10. Let's see if we can do this for our three-digit number. So once again, as you know, you only can have zeros and ones, but now we have three digits. So we can use our cards again to drag them down, maybe. And I can take it and I can say, oh, I'm going to use all zeros. So that's one combination. And you're going to notice that I've stacked a lot of zeros and a lot of ones, so you have plenty to work with. So our first combination here is 0, 0, 0. Now, if I wanted to just change one digit in this, I can get a new number. So I can drag 1 in, and now I have 0, 0, 1. That's a possibility. I could drag my 0 out of place, move that 1 over. I got another possibility. So now I've got 0, 1, 0. If I move that 1 again, let's move it over here. Move here, that here. What I can get is 1, 0, 0. Now we're starting to get lots of combinations here, and you can imagine that we can start changing it up again. Why don't I get rid of this 0, and now I'm going to start working with two ones, not just one 1. So I could once again have 1, 1, 0. What if I moved that 1 around and move the 0 around? Then I can get a new combination. It's 1, 0, 1. So at this point, we have 6 combinations already. Okay. There's one we haven't done yet, I think. Let's see. We have one. We haven't done. One, one, one. Now that gets us up to 7 combinations. There's one more. Can you figure it out? Pause the video right now and see if you can figure out what the last combination would be. We have 7. There's actually 8. Do you think you can figure it out? Well, I hope you did some moving of those tiles yourself so you can see what I just did. And what you're going to find out is that the combinations that are possible is 0, 1, 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1, 0, 1, and 1, 0, 0, which gives us 8 combinations. Now this system works the same way when we add up a digit. So what I want you to do is start doing this process for 4 digits yourself. Now, there is more than 2 and more than 4 and more than 8 combinations. But how many could there be? Now, one of the ways that gets really confusing is that which ones have you done, which ones you haven't. And you might have noticed that I started just kind of moving one number at a time around, which can help you keep track. So let's see what we've done so far on a chart before you go back and do that. So if we had one combination, one digit, how many combinations could we do? Oh yeah, it was 2, right? And we had 2 digits. How many combinations did we have? We had 4. And on 3 digits, how many combinations did we have? Oh, it was 8, right? So now we have 2, 4, 8. Can you see the pattern that's happening here? 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 8 is 16. So do you think there might be 16 possibilities when you have your 4-digit number? Probably, right? So when you go to the 4-digit number to go then, you're looking for 16 combinations, okay? Now that might seem difficult, but it's actually not that hard, and you can figure it out, I'm sure. So I want you to go back, do the 4-digit numbers, fill out this chart for the rest of yours. You can check your answers. I mean, I've given you most of them already, but you can check the rest of your answers there. And then you're going to go on and answer the questions in the next slide and predict the numbers above the ones we're going to do with the cards. Because once you know the pattern, you don't really need the cards anymore, do you? No, there's a challenge question. If you really get it now and you want to do the challenge, go for it. If you're not quite ready for the challenge, don't worry. Just make sure you fill out all of the red bubbles with the correct numbers. Fill out the 2 charts and answer the open response question and submit it to your teacher. If you're still having trouble with binary numbers, be sure to contact your teacher and ask some questions. But I'm sure you've got it now. So, in summary, when you add a digit to a binary number, you double the possibilities that you can have, which makes a lot of sense on how we can very easily get from only 2 numbers, but zillions of possibilities, which allows us to code for zillions of things. So, hope this helped. Go back if you haven't already filled it out. Fill it out, submit it, and then you can start your new work this week, which carries on from binary numbers introduction to counting in binary and taking decimal numbers, the numbers that we use every day, making them binary, and then making those binary numbers back into decimal, which will lead us to many possibilities. And by the end of the week, we'll be able to run Google. So I hope this helped. Have a great day, and have a good week doing binary. Bye.